Hi everyone, so in today's video I want to have a look at Polymer's second year revision. So what we'll do is just quickly recap on what we had to talk about from last year. So first of all, you need to be able to identify the four different groups of polymers and their properties. You have to be able to give you different examples of each of them and then what they could be used for, what additives are and how they can be used, and then what the different symbols that you will find on the recycling table mean. So first of all, I know I just said there was four groups of polymers, but actually to begin with, for the main part, there's three main groups. So there's your thermosets, your thermoplastics, and your elastomers. So thermosetting plastic, which we have on the left, so these are the ones that can't be recycled. Now the reason they can't be recycled is because you've got these rigid cross links between each of them. Now they're called van der Waals bonds, and what happens is when a thermosetting plastic is heated up and set into place, they become rigid and they can no longer be altered. So what would happen if you tried to reheat them again? It would just sort of go into a gloopy mess and it would not be used for anything. It would just be ruined. So yeah, thermosets can't be recycled, so the areas around that is thermosetting plastic, so it's always set in place. Next you got your thermoplastics, the one in the middle. So this is really easy to be moulded into shape. It can be recycled. Now the main reason of course is because if you look at the difference from thermosets to thermoplastics, you no longer have those van der Waals bonds anyway. You've just got the fibres of the plastics going across quite easily, so each time you heat it up it can be formed nice and easily. So what will happen eventually, if you recycle it too many times, eventually it sort of fades a little bit and it does lose some of its integrity, but it can be recycled quite a lot, quite easily. And then you've got your elastomers. So these could be either a thermoset or a thermoplastic depending on what you've got. And elastomers basically are elasticy, so you can deform it, and once you let go it will go back to its original place. If you think about things like elastic bands or neoprene or things that, like wetsuits, dry suits, those types of things. So those are the three main groups of polymers that we looked at from last year. So with your thermoplastics, the main ones you need to know about were things like LDPE, which is low density polyethylene. Now in the exam you are allowed to just say the shortened name. You're not expected to have to say the entire name, because if you say the entire name and you spell it wrong then you will lose marks. So LDPE typically is very tough, good chemical resistance, and it's weatherproof. HDPE, which is high density polyethylene, weatherproof, tough, good chemical resistance. Polypropylene, PP, good chemical resistance, tough, good fatigue resistance. You got HIPS, high fat polystyrene, hard, rigid, tough. So HIPS is what you would use in like the vacuum former. ABS, it's extremely tough and rigid, so that would be when you have things like the soap dispensers you have on the walls and plug sockets and things like that made out of ABS. PMMA, tough, hard, good chemical resistance. Nylon, which is corrosion resistant, good temperature resistance, and low coefficient of friction, which means if it rubs it doesn't get heat, it doesn't cause a lot of friction, doesn't create heat or anything like that. UPVC, so that is slightly different to PVC. So UVPVC is rigid, opaque, tough, good weather resistant and fire retardant. And then you got PVC, which is tough, flexible, good weather resistant. So the difference between UPVC and PVC is PVC is flexible and UPVC is rigid, so it's solid. Now the C in PVC does stand for chloride, so chlorine, which is why you can never use PVC in things like a laser cutter, because it makes fumes that creates chlorine gas, and chlorine gas is deadly. So those are your thermoplastics. So these are the ones that can be recycled under the right conditions. So your elastomers, so you've got ones like natural rubber, so good tensile strength, so tensile strength being it's being able to pull the parts. Good hardness compared to other elastomers, it's tough, it's a good electrical conductor and good cold resistance. You've got BR, which is tough, excellent wear resistant against friction, good thermal resistance and good electrical insulator. You've got neoprene, which is good thermal resistant and tough, so that's why neoprene typically is used in things like wetsuits, dry suits. And then you've got silicon, which is really good flexibility at low temperatures but poor abrasive resistance. So for example, if you were to make clothing and had like a silicon on the outside and you sort of had a crash and you skidded across the floor, it would just disintegrate very quickly. Then you got your thermosetting plastic, so you got your urea formaldehyde, which is hard, good heat resistance, quite brittle, but it's a good electrical conductor. So you then got melamine formaldehyde, so that is hard, opaque, tough, food safe, chemical resistant. So that's why melamine formaldehyde is typically used in things like kitchen counters. Polyester resin and epoxy resin, rigid, tough, good chemical resistance. So what I haven't done there is talk about the uses, because what I would like you to do is for each of those, for the thermoplastics, thermoelastomers and thermosetting plastics, is once you're going through, because you've seen the name and the properties, can you think of any uses because of those properties? Remember, when you talk about the uses of things, you need to sort of reverse engineer the answer. So you know, okay, I want to make a plastic bag or a children's toy that needs to go outside. Okay, so what properties does a children's toy that goes outside need to have? It needs to be hard wearing, it needs to be weather resistant. So you can look through and go, okay, which plastics will be most appropriate. So that's the best way to try and figure out what plastics will be used for what job. So then the fourth group, remember I said originally there's 4 groups, and like I said actually no, there's really 3. The fourth one, which is sort of like a new type of plastic, is biodegradable polymers. So these are ones that are easily biodegradable. They do not have a negative effect on the environment. So these are things like cornstarch, potato pack, biopol, PLA, lactide, and things like that. So these are being made now to sort of replace the other 3 types of polymers, because we're looking to a future where we no longer have oil, so we can no longer make new plastic. So we're looking at making them in different ways. So typically, mainly there's one of 2 ways. You either got natural or synthetic. So natural being that it comes from vegetable or plant starch and things like that, so it's extracted from natural sources, whereas the synthetic ones tend to be made in labs like PLA, so they are extracted, but it includes chemicals to make them. Okay, so the same thing, have a look at those, and I also want you to try and think, okay, look at those and what uses might those have, looking at the properties. So a typical one you'd find, actually, potato pack now is being used quite a lot in lunch packs. So if you ever go and buy lunch from like Marks and Spencer's or Pret a Manger or things like that, and you get like the plastic forks or like plastic plates, potato pack is typically what that's made out of, because it's really easy to break down. So then we had additives. Now remember, additives were the things that you added to polymers while they're being turned into something to improve their properties. Now there's a huge variety of different additives that you can have. Things like fillers, flame retardants, plasticizers, stabilizers, pigments, anti-static, and biobatch. So they all do certain jobs. So fillers, essentially, while say you're making a children's toy for injection molding, and you want to reduce the cost by not using as much of your polymer, you just add fillers in there to bulk it up, so you're not using as much. Your flame retardant, you would add if it needs to reduce the risk of combustion, of going up into flames. Your plasticizers increase its ability to flow. Now flow literally means its ability to like pour and move. Okay, so particularly if you're, say, injection molding, or you are like other production methods like that, and it needs to pour into a mold easily, you would add plasticizers, because it would make sure that the plastic gets into all the holes, all the parts of the mold without too much trouble. Your stabilizers, so that prevents things from biodegrading in UV and sunlight. So if you were making plastic like garden chairs and things like that, you need to have stabilizers to do that, so it wouldn't break down. Pigments just let you change the colors quite easily. Anti-static, that stops the buildup of static electricity, because the reason why some plastic products attract dust quite a lot is because it's just quite staticky. So what they do is anti-static adds a little bit of moisture to it, so dust can't stick to the surface. And then biobatch, that allows things like PE and polypropylene to be able to biodegrade quite easily. So those are the main additives. We will look at additives in more detail in a separate recap, but those were the main ones and what they do. So as with all the other topics, when it comes to the actual exam practice, yes, you need to know each type of material, so woods, metals, plastics, papers and cards, things like that, but it's more about how you apply it in a question. So typically you'll probably have to join 2 or more topics together. So it might be one part will ask you about a type of polymer, but then it will ask you how it could be used to make a certain product, and I'll keep using that example of a children's toy. So you'd have to know about the manufacturing processes for plastics, or it might ask you to compare it to a similar product that's made out of wood or metal. So it's important that you can combine a couple of different topics together to help you. So now what we're going to do, have a look at a couple of questions. So what I'm going to do is I'm going to talk through the question with you, give it a bit of breakdown. I want you to pause the video and have a go answering the question. So image below shows a disposable sauce container made from polypropylene, PP. Analyse and evaluate the positive and negative implications of manufacturing the container from biodegradable polymer instead of polypropylene. So that is 12 marks. So reading that through, 12 marks, so realistically you need to bring up 6 points and then discuss and explain them to get another 6 points. So that gets you your 12 in total. So it says there it's after positive and negative. So if you break that down again, you're looking at 3 positive points and 3 negative points, and then explaining each one of those points. And then that will get you your 12 marks in total. So whenever you see the longer mark answers, and you see it's like a 12 mark, 15 marker, don't panic to begin with. Just start breaking it down. Read through the question and break it down. So straight away, 12 marks, okay, so I need to do this 6 things I need to bring up, and then I need to, with evidence, explain myself, gets me out of the 6. Okay, from then, okay, positive and negatives, so split it in half. So actually that's 3 and 3. So actually just 3 positives and 3 negatives. That doesn't sound as challenging, that's not as bad. So can you please pause the video, have a go at answering it. So give yourself 12 minutes, have a go at answering it. You can use your notes in your textbook, and then I'll go through the answers. Okay, so typically you could have had any of these. So polypropylene is produced from a finite non-renewable resource, so it's going to run out at some point. PP doesn't break down as quickly once discarded, so odds are it's going to sit in a landfill for most of the time. PP can be recycled, so you can encourage people to recycle material. Biodegradable polymers can be made from natural materials, which are non-finite, which means that we're not going to run out, so we can keep making them over and over again. Biodegradable polymers break down a lot quicker, so they're not going to sit on. If they go to a landfill, they'll break down in a year or two quite easily, quite quickly. You can degradation of biodegradable polymers can be caused by influences of chemicals, water, heat, light, or microorganisms. So that's when you can add things like additives to improve its ability to be broken down quite easily. So that's just something you add in the manufacturing process. Some biodegradable polymers can leave toxic residue once they've been decomposed. So you could have the problem where it does go to a landfill, it breaks down quite easily, but then it just sort of poisons the ground around it. Natural biodegradable polymers need land to grow the crops, so that actually means that you need quite a bit of agricultural land to be able to harvest to sort of make these polymers. So any of those, you're looking for 3 positives, 3 negatives that you can then just say, back up your evidence, and then have your comparison. So next question, state a disadvantage of using oxidegradable polymers. Name a suitable polymer for the fruit packaging, and then give 2 reasons why this polymer is suitable. So total of 5 marks. So first one's that easy, it's a simple 1 mark answer. Now if you don't know what oxidegradable means, you can sort of just break down the word quite easily. So oxygen, degradable means it breaks down, so okay, a plastic that breaks down in oxygen. So that's quite a simple way of breaking it down. Name a suitable polymer for the fruit packaging. Again, a simple 1 mark answer. So you then obviously need to make sure, because it's linked to the first part, you say a suitable polymer that could be oxidegradable. Okay, and then the next question is 4 marks. So give 2 reasons why this polymer is suitable. So 2 marks for each reason. Name the reason and then explain it will get you your full marks. Again, if you're not sure, look for clues in the question. That's always the trick when it comes to A-level questions, is if you don't know, look for clues in the question it's given you. So you know it's going to be a food container, so you know, okay, what kind of properties does a food container need? Well, it needs to be food safe, so not poisoning anyone, it's not contaminating the food. And then in questions like this, it's also a good idea to talk about the manufacture of the packaging, because if it's asking you why it's a suitable polymer, it will want, okay, it is food safe, so it won't contaminate the food. That's an easy one. But then you can say, okay, for manufacturing, you can talk about how it's easy to mass produce because it can be made in, and then you talk about the way that it can be produced. So can you stop the video, Give yourself 5 minutes, try and answer the questions for me. So what you've got is products, so state disadvantage of using oxydegradable polymers. Typically they are more expensive and they are quite difficult to recycle. Name a suitable polymer for fruit packaging. You could have had something like HIPS, PET or PLA. What you can't say is anything like polystyrene, polypropylene, acrylic, ABS or any thermosetting plastic like that. So give 2 reasons why polymer is suitable. So say for example we said HIPS. So what you say, first of all, we said it needs to be food safe. So if you said the second one here, it says it's food grade, so therefore it's not going to contaminate the food, quite easy. And then manufacturing, HIPS, it can be vacuum formed. So if you think about how many packets of grapes you have to make a day, you can vacuum form those really, really easily. So next one, so name a suitable specific metal for part A of the cup. Explain 3 reasons why this metal is suitable. Use notes and diagrams to explain how part A of the cup could be used, and then name a suitable specific polymer for part B and explain why it's suitable. So this is one of the examples where you're combining 2 topics together. So we've got a mixture of metals and polymers together because it's a product that uses both of them. So that's what we mean before when we're saying it's important that you can combine and compare 2 different topics together. Okay, so pause the video, have a go, use your textbook, your notes to try and answer, and we'll talk through the answers. So suitable metal for the cup, most commonly most people probably said things like stainless steel, aluminium, probably. They're always the go-to ones quite easily. Explain 3 reasons why this metal is suitable. It's tough, therefore it withstands impact, so it can't be dropped. Doesn't corrode, doesn't rust. It looks quite nice, it's aesthetically pleasing and easy to drink from. You'd be put off if it was rusty, so you wouldn't pick something that rusts. It's malleable, so it's easy to be formed. So any of those types of things would be fine. Again, so obviously 3 reasons why it's suitable at 6 marks. 3 reasons and then back that up with an explanation as well. So C, use notes and diagrams to explain how the part A could be made. So typically it's probably either spinning, press forming or cupping. So if we look at some of the stages of it, so what you'd have is sheet steel is enrolled from stock material. It's then annealed to make it more ductile so it's easy to move around. Its material is then punched to make a blank. It's then clamped onto the former and the die moves down with the hydraulic press to draw out the material to take the shape of the die, and then the product is removed, deburred, which is get rid of all the rough edges around it, and cleaned. So that is 10 marks. So if you don't have a diagram, you can only get 7 marks. So anytime it tells you to use a diagram, you need to use a diagram. So that is quite important. Obviously I've not got diagrams on there, but for what I've just described there is cupping. So we said cupping / deep drawing are very similar processes. And then question D and E, name a suitable specific polymer for part B. So we could have had polypropylene or LDPE, HDPE, anything like that. And then why is it suitable? So you said it's food grade, so it won't contaminate your drink, non-toxic, insulator, so it'll keep it hot or it'll keep it cold depending on what you're going to do, and it can be injection molded, so it's easy to produce. So that's a typical question where actually if you're looking at the questions, they've covered quite a few topics in there. So not only have they covered plastics, they covered metals, but then they've also covered manufacturing processes. So you've had to talk about a metal manufacturing process and a polymer manufacturing process. So that's covered 4 different topics in one question. Okay, so obviously that's quite a big question. So that is worth how many marks? 7, 14. That's worth 24 marks in total. So that's a big question broken down into 5 different parts. So that is polymers for the 2nd year revision. I am going to upload a video as well for polymers for the 1st year if you want to have a recap on there. But please do just start looking at exam questions and start looking at how you break it down. At this stage, it's absolutely fine to be using your notes and your textbook to help you. It's just how do you sort of attack the questions, looking through it, looking for tips and like what sort of ways, how many marks is it worth, how do you break it down, what topics is it actually asking you. If you've got any questions or any requests in terms of videos or sort of exam techniques, send me an email and I'll do my best to work my way through and upload them for you.